Since the last time we've met, you know what are sine and cosine. That's cool. Today we'll discover the third guy of the Trigo team, tangent. Tangent is, how to say, another kind of guy. Hola amigos, nice to see you again. If you haven't watched the first video of this series, please do it before this one. The link should appear somewhere on the screen. So, let's get started. I assume you've seen the first video. And I assume you may say, okay, we've learned about sine and cosine, but hey, what about tangent? I didn't forget. It's just that the case is a bit different and it deserves its own video, hopefully shorter. Let's first understand what a tangent is in general. A tangent is a stolen kiss from someone you've never seen before and that you will never see again. These are tangents in orange. A tangent is a straight line that comes from nowhere, touches a curve, theoretically in one single point, and goes away. A circle, a parabola can have tangents. So, if we're speaking about tangents, we're speaking about curves. Do you remember the circle we used in the last video? This circle. Okay, so I'm going to draw a tangent vertically on the right side of the circle. Here it is in blue. And I'm going to extend the hypotenuse. There we go. The hypotenuse meets the tangent line and forms this with it. This is what we call the tangent in trigonometry. It's the length of this line. Where to read the length? Easy, just project the point to the vertical axis, like with the red arrow here. So you can see that for this given angle, the tangent is approximately 0.75. Now, I'd like to point out something. I told you that I made a separate video for the tangent because it was somehow different from sine and cosine. Let's look at the main differences. First, compare these two graphs. So, the sine is the opposite and the cosine is the adjacent when the hypotenuse is 1. But let's have a look at the tangent now. The tangent is the opposite when the adjacent is 1, not the hypotenuse. The adjacent, basically our unit triangle here is not this one, but that one. You may start to find all this a bit confusing. Don't worry, this is only temporary knowledge that you need to understand the next video. Afterwards, you can just forget about it. I mean, you can forget the details, but yeah, you know. Now, another difference that you must not forget. Look, this is the tangent of an angle around 50 degrees. What's its value? We read it here on the vertical axis, around 1.2. Do you remember? Sine and cosine couldn't be more than 1. The tangent can be more than 1. Now let's play a bit with the tangent. Let's open the angle and see what happens. On this animation, we can change the angle in a continuous way. Let's start with a tiny angle and open progressively. As you can see, when we pass 45 degrees, the tangent passes 1. And then increases quicker and quicker. So I have to zoom out in order to follow it. Here we go. As you can see, it quickly goes out of the screen. And when you get really close to 90 degrees, the tangent gets really close to infinity. I told you that tangent was different from sine and cosine. Let's summarize everything first in one sentence. The tangent is the opposite side when the adjacent side is 1, okay? Well, time for a little practice. I leave you with this. Pause the video now and resume it when you're done. So, how did it go? Here we have a right angle triangle. One of the other angles is 21 degrees. We're looking for the opposite. We know the length of the adjacent, 11. So basically, this triangle is 11 times bigger than the unit triangle. If the adjacent was 1, the opposite would be tangent 21. So x is just 11 times tangent 21. We can use a calculator for that. 11 times tangent 21 is 4.22. Okay, here is another one, a bit harder. Pause the video now and try to find it. So, how was that? Let's draw our circle to see the situation better. It's head down, but it should be okay. Here, x represents the adjacent side, so this triangle is x times bigger than the unit triangle, which means that 21 centimeters is x times the tangent. Let's write it. 21 equals x times tangent 48 degrees. I want x alone, so I'm going to divide both sides by tangent 48, and simplify the fraction and get x alone. Now I just flip it. To have it on the left side, I can replace tangent 48 with its value, 1.11, and it makes approximately 18.92 centimeters. That's the value of x. Before we do a last training, I'd like to summarize a bit and to make you notice something. Let's put the names of the three sides of a right angle triangle on this, and let's write what we have learned so far. First, the cosine is the adjacent when the hypotenuse is 1. Second, the sine is the opposite when the hypotenuse is 1. And third, the tangent is the opposite when the adjacent is 1. So basically, we now have something related to the angle that links each side to the two other ones. We're complete. We have now everything we need to solve all our problems. The sine of the angle links the opposite with the hypotenuse. The cosine of the angle links the adjacent with the hypotenuse, and the tangent of the angle links the opposite with the adjacent. Every side is now linked to every other one. So, ka and toa may already sound familiar to you, but it will be for the next video. I promised you a last training before you go. Here it comes. You have to find the measure of the angle A. I let you pause the video the time you need. Resume it when you're ready. Let's see that together. Which sides do we know? Well, we know the adjacent and the opposite. Adjacent and opposite, it sounds like a job for tangent woman. Let's remember well. The tangent is the opposite when the adjacent is 1. Here the adjacent is 15. So the triangle is 15 times bigger than the unit triangle. Everything is 15 times bigger, which means that the opposite is 15 times the tangent of the angle A. So we write 17, the opposite, equals 15 times tangent A. I want tangent A alone, so I divide both sides by 15. Then I cancel the two 15s and flip it to make it look better. 17 divided by 15 is 1.13333, and I know we're not done. We have the tangent, not the angle. Let's use the calculator to get the angle. It makes around 48.6 degrees. We are done. Great, amigos. I hope you understood it. Please like, comment, subscribe, share this video. Ask your parents to support my work a bit on Patreon, please. I would be very, very grateful. The link is below. Next time we'll speak about the famous so, ka, and toa. Homework. Go and have potato chips in front of the TV because you deserve it.